Here goes. Okay, basically this video is about the property of electric motors, and it's something that I never understood about them but discovered recently is the fact that the voltage has a lot to do with how much amperage a motor will allow to pass through it. I used to think that because amperage was the key constituent and the strength of a magnetic field, that the more amps you pass through a motor, the stronger it would be. Well, the reality of the matter is that sometimes you have to up the voltage in order to pass a certain amount of amperage through it. And basically what I'm about to show is I'm going to connect this motor up to a 370 amp transformer that only puts out 8.45 volts. Then I'm going to connect it to this transformer here, which is 28.8 volts and 18 volts. It's an old 15 amp battery charger transformer that I took out of a charger. And what you're going to observe is the fact that voltage is more important than amperage. And this is important when you're going to build certain machines that have these little motors in it. I used to always wonder how a 12 volt 300 amp battery charger wouldn't burn up a windshield washer pump. Well, this video is about to show something about that. 18 volts. I don't know if you can already hear it. Have it connected to this here. See if you can see in there. That's 18 volts. Now I'm going to turn it on the 28.8 volt setting. That's on the lowest setting right there. So here goes full power at 28 volts. That's about 1 amp right there. There was 9 amps of peak, dropped down to 2 amps. Do that again. 9 amps, 10 amps, back down to 3 amps. You can see these motors are nearly similar in size, but another constituent of electric motors is the size of the winding and number of turns. One amps with dead stop. Now I'm at 28.8. The lowest setting is barely pulling 0.01 amps. Okay, that's full blast. It's still full blast at 28 volts. I'm at 0.0 amps, 0.02. Holding it at dead stop, it only draws in 2.5 amps. This is 28 volts. That's on the lowest setting, and it just pulled 6 amps and burned itself out, I think. It did. I just killed it that fast. This is now hooked up to a 300 amp transformer, 370 amp. Pulling 0.7 amps right, or no, this is 8.45 volts. I'm not even pulling 1 amp at full power. big difference, even though that's a serious amperage, because it's only 8 volts. It's only letting about 0.7 amps through. I'm going to try something else here. Now I have it crimped off at a dead stop. Right there it's pulling 4 amps. I'm going to turn it up all the way. It's pulling 17 amps at dead stop. So still, even though it's a 300 amp transformer, at dead stop it would only pull 17 amps through the motor. So it didn't really fry it like you would think it would immediately. Here is the battery charger, cooling fan, 28 volts, 18 volts. Okay, basically what I got here is the power supply that I built for doing all different types of experiments. I don't have a very good camera, so you're going to have to mind all the bad shots. But anyway, these electronics here are just a battery charger that's got power level indicators and all that, and tells you how charged the battery is. This little fan right here just basically cools off the mott. The mott is a rewound microwave oven transformer that uses copper tubing in the secondary that water is circulated through from this setup here. And basically I'll fire that up. I also use this device while running this. This is a very useful electrical component. It's a router speed controller. Basically this here is the cooling pump. Turning that on fires it up. I don't know if you can see the water drizzling out. It doesn't really need to flow that fast, but here's the cooling fan for the mott. Here I got the mott on its side. It seemed a little bit easier to cool it off that way. That fan sitting in front of it. And this here is the diode array. I've got 5 diodes on this. 4 of them are connected to this little setup here. It'll be using for electrolysis and all this. This supplies around 370 amps at about 8.45 volts. You can see how that's connected. Basically, these are just big fat bus bars that I've soldered a bunch of heavy gauge copper tubing to, and they still leave a lot to be desired. They need to be thicker than that. I'm not sure if you can see. And it also has a cooling fan. You can see that fire up. All these bus bars you see are what I use to connect clamps to. I've been using all these to connect clamps to, like this. These are all different voltages. This is just a high amperage AC. This right here is my 25 amp DC. These terminals here are the 370 amp. This little diode right here on the back is the 5th diode. That's connected to this transformer here, which is an old 28.8 volts and 18 volts. That's an old battery charger.